Okay, hello everybody, it's Matthew here. This video is primarily addressed to Andre, but anybody in the OpenEMR community is welcome to join our project. The project is the Chart Summarization Research Project. So we're looking to use advanced open source technologies such as cTAKES that perform a very complex series of text evaluation using machine learning to figure out what a certain corpus is all about. So where this is useful is when you don't have structured data like vitals. Um, let's say that instance is SOAP notes. That's not structured. Vitals is structured. How do you know what exactly is happening whenever a doctor fills out SOAP note? Well, you can run it through a machine learning process that does something called natural language processing against a clinically validated data set. And so when doing this, you can start to see what that data looks like if it were somewhat structured. And there's always a little room for error, but this is the kind of best the academic world and the open source world have to offer right now. So let's get started. The goal of this video recording is to get to here. So this colorful screen is what is called the text analysis output that allows you to traverse the text to see SNOMED codes and diagnoses and other relevant details about freeform text. And so we will be able to set everything up, and this will be the output. So this is the goal. So where this starts is with a branch on the repository called cTAKES Docker. Tim is his name. He's a very nice gentleman that runs the project, and I've been working with him for the past several weeks to kind of get the project to work for our use case. And so you'll need to pull down a special branch. It will eventually be merged in, but the best place to go is to github.com/tmill/ctakesdocker, and you'll see a pull request here called some various enhancements. And this will probably be checked in very shortly. Tim is pretty quick about code reviews and things of that nature, but what this has in it is a README file, and among other things that we'll be looking at today. So I'm going to open that README file up, and it will start to talk about how you set up cTAKES on your computer. So I've already done most of these steps, so I'm going to kind of just quickly walk through any lessons I learned and any notable items. So the first thing to do is to go and basically run this code. You're going to have the end result of, if I cd into the off directory, you'll have the end result of this Apache UIMA folder. And this is the Apache. You can think of it as kind of like the runner of the whole pipeline. So this will be installed, and then you'll be told to execute the command to set it as a environment variable. So then we'll be able to use it later. Okay, so the next thing, going back into the repository on my special branch, is you're going to have to make some adjustments. We're not using what's called de-identification. This is basically if you input John Doe as the patient, it will change it to something random like foobar, and all associated codes and diagnoses will be kind of mixed up, so it doesn't look as though John Doe was the patient, because you don't want to give that information away. We don't really care about that because we're going to be using this in a clinical setting, so we don't have to worry about hiding away those details. So we're going to skip this thing that says sharp and mist. This is a special proprietary data set and model for processing the data so that you can de-identify it. So we don't have to worry. Anytime we see that, we can skip past it. So in this light, there's a section specifically on skipping it. You'll need to run the following commands. They're using sed to edit the file configuration directly. Right inside of the, if I print working directory, you'll see my folder path here, and then you see the repository. And then if I do an ls, you'll see the folders. Inside of each of these folders here is a special configuration, and these will, by running these commands, they'll edit it so that we use the totally non-de-identified solution. So you'll just go ahead and run those. Next up is a really important step for the env file. So first thing to do is to sign up with the government website, UMLS. And this is the National Institute of Health's kind of take on classification and standards around data, bioinformatics, things of that nature. So you'll sign up here. It takes about a day for them to process it, like a business day is my experience. It only took a business day. So you can sign up. That will give you access. It's free. They don't spam you. And then you'll be able to insert it into this env file. So I don't want to show my file because it has my password in it, but I put together a dummy kind of file that shows, like, here's my UMLS username, Matthew Vita, and then you can type in a password here, and then underneath it, you need to figure out what your local host IP address is. In my case, I was using ifconfig, and I found out that my local DHCP issued address is 10.0.2.15. This is important because the containers, the Docker containers that is, they talk to one another, but they have to go through the host as a means of communication. So kind of complicated. Let me know if you need any help. It should be pretty easy. If you're not using a virtual machine, it should be very easy. I'm unfortunately using a virtual machine, and so if I show you, I get a lot of junk, and it was hard for me to find my actual address. So if you have this problem, I can help out. In this case, we see it's actually ENP0S3 that gives up my address, not like the traditional ET0, like Ethernet 0. So, if you have that problem, let me know. I can help. That's actually the solution. It's going and looking for this particular interface. But anyway, so we will then, make sure that it's saved. Obviously, it says here there's a sample version, and you must save it to envfile.txt. So it's just renaming it, right? Okay, so next step is to build the containers, and I have a note here saying you can skip the missteps because we don't care about de-identification. I already did this. The build's pretty quick. They take under an hour if you have a bad internet connection. That is, my internet has been kind of slow, so it took me about 30 minutes to download everything within inside of the container. The containers themselves basically do a wget out to the Apache website to download big programs up to almost a gig, really. And the servers aren't very good, but they work, but they definitely take a while. So before we even jump into this, here's how you install Docker. This is my personal guide, so there's some stuff in here that you can ignore, like this vert padding function and these info keywords and stuff. All you really have to care about are the highlighted areas. So first is, making sure you're using a Debian system like mine. I'm using Linux Mint, but you can use Ubuntu or Linux Mint. Just any kind of Debian style will work. So we'll first add the key to the Docker remote host, and then we're going to add a special repository for getting it. And then we update our package manager so it can see the new, available Docker packages. And then we install Docker Engine. Now, there's a weird thing when you install Docker. You'll only really be able to use it as a root user, which is silly. So what you have to do is you have to modify it so your user will work. So just replace Matthew with your Linux username, basically. So yeah, it's just simple as that. And Docker's installed. You can kind of think of Docker as a virtual machine without bloat. Basically, it's really lightweight. It's almost like a virtual machine, but it's not running another operating system. It's sharing the kernel space, which is pretty cool and has taken over the technology world pretty strongly. Okay, great. So now that we've installed Docker, we can skip mist, and these indicate to the left here, these keywords and then the greater than symbol indicate the directory it is in. So we'll go ahead and cd into each of those and run the respective commands. So if I go back and I were to cd into AMP broker and then copy this in, I'm not going to run it because I already have my image built. If I can run it, it's going to build it, but it's very fast. Doesn't do anything because it's idempotent, but the actual processing will take about 30 minutes, so give it some time for downloading. Next up is the clinical pipeline processing unit. So we're going to cd back, and then we'll cd into it and run the command as well. So if you do Docker images, you'll see cTAKES as a pipeline. I made it 3 hours ago, and then AMQ image made also 3 hours ago. And then you could ignore the other stuff. That's just, test stuff. And it's kind of funny. You can kind of see that the cTAKES one is almost a gig. So there's a lot of stuff it downloads and uses. So it's going to take a little bit of time. But that's ultimately what's doing the majority of the work. All right, so once you run those, you're going to start each container at the root of the repository. So you can go ahead and run this. I already have it running. If you do Docker PS, this kind of gives you an idea of what's running, and I see I have my two things are running. The difference between an image and a container is an image is kind of like the raw, I don't want to use the word binary, but I guess it's the easiest way I can think of it. It's kind of like the program's binary, and then a container is like when you're running that. So these are containers using a particular instance. So these can be destroyed and shut down and turned on, but the image is kind of like what you build. That's kind of like the binary, similar to how you would install a program and uninstall a program. So hopefully that makes sense. You start all of your containers, and now we're going to use that Apache tool, the UIMA, to actually start doing some work. So go ahead and copy that in, run it, and a Java program called the CAS Visual Debugger will load. CVD. CAS is their kind of format for this analysis of the documents. So we're going to go into Run Load Analysis Engine, AE, and we're going to definitely select Remote Node DID, because this is like not needed. We don't need to do de-identification, so we're definitely going to select that. Just because it cached mine, I'll show the whole directory structure. We have my user, the repo, and this desk directory, and then remote node de-identification, and then hit open. All right, and so now we can see to the run area. In the run area, we see a run aggregate with de-identification. It's not actually doing de-identification. It's just the label that's checked into the repository. So just please ignore that. So for testing, I've been using this nice sample visit note from the UNC School of Medicine. And so I'm going to go and copy this. It's all fake data, but realistic. Copy it into the right-hand corner here. And then I'll hit run. Give it a minute to process. It's already done because I can see here it loaded up 1,800 annotations. This view is very complex and not really human readable. So it's good for a computer, but it's not good for a human. So I'm not going to encourage the use of it. So what I will encourage the use of is hitting File and say Write XMI CAS file. So this is a special, the special format that we talked about for the analysis will be saved as a file on the disk, and then we can refer to it later. So I'm just going to call it my patient visit note for Joseph Smith. Hit save, and then of course next step is we can get rid of the visual debugger, so I can hit Control-C to kill it. And on my repo, I have some special instructions for seeing it in an easy-to-use, visually rich editor, seeing the annotations, that is. So you simply run this, and it's going to load up a Java program. It's all Java. And then you select your input directory. I had one called output that I was using for testing. You don't need that. And you're going to select the same analysis engine you used to process it. Same kind of area here, Matthew, cTAKES Docker, desk, and then remote node de-identification. Hit open, hit view, and remember ours was called, John something, my patient something rather. I have a lot of stuff in my home directory. Apologize for the clutter. here it is, my patient visit note for John Smith. The default is the Java viewer, so we're going to keep that, and we're going to double click it. And now we have the visual viewer. And so if I show an example of an allergy, oh, this is no known allergy, so that's not a good example. I'll click on aspirin. I'll click on aspirin, and then I see there's a medication mention. So I'll bring that down, and it's color coded. See how it matches with the yellow, and we see yellow is the medication mention, among other things. It could also be other annotation types as well. Click on ontology concept. We can start to see inside of these the associated SNOMED code. So we have the OIDs in here, which is really nice. So where that leaves us with this project is it's a research project. So we want to make sure that this tool produces useful output. You know, is it actually providing us with the correct clinically annotated output from something like a SOAP note, right? Because vitals is easy. That's structured data. I can identify exactly what's going on, but with something that's free form like a SOAP note or just a general free form encounter form, you know, however a user customizes OpenEMR in the encounter space, you know, is this a good tool for that case? Can we then open up the XML output and parse it via PHP? So this is the non-human readable output for computer to process ontology concepts, you know, that we were just looking at is defined in XMI format. So this is an interesting project. I have, you know, a lot of good feelings about being able to see the SNOMED and RX norm codes as we see here. I think that's going to be helpful, but I'm not a clinician, so I can't verify that they're correct, nor if they provide value. So I think that's where Andre will certainly help, and I think other folks might be interested in the community now that they're seeing some momentum on this project. It's using the latest technologies out of academia and open source. So, okay, I will leave it there. Please reach out to me. I'm free to help with any questions. I realize there's a lot to this, so thank you so much.